performance motorbikes are exhilarating to ride. They give you an incredible feeling of freedom, but that thrill comes at a price. When a rider comes off at high speed, for whatever reason, he needs all the protection he can get. In motorcycle crashes, head injury is the principal cause of death, which is why the helmet is the biker's most important piece of equipment. So how do they make a helmet that can save a motorcyclist's life? Braunschweig, Germany. Welcome to Schuberth, one of the world's largest producers of protective helmets. They've been making crash helmets here for over 50 years and now produce more than 1.5 million of them every year. And here in Braunschweig, every design is exhaustively tested to ensure that it meets the highest safety standards. It's reckoned that wearing a helmet improves a motorcyclist's chances of surviving an accident by almost a third. But Schuberth needs to know their helmets are up to the job. So for every batch of 3,000 helmets they produce, they try to smash a dozen of them to smithereens in their labs. If they're not up to scratch, the other 3,000 are destroyed. The most demanding trial measures shock absorption. It reproduces the force of a driver hitting a wall at 30 kilometers an hour. That's 5 times faster than the speed at which the human skull will crack. You wouldn't want your head to be inside the helmet when this happens.
3, 2, 1.
Ouch. So, would you have survived? Well, you'd certainly stand a chance. The dent shows that the helmet absorbed the impact, but still retained its shape.
Those cracks actually just mean that the helmet is doing its job.
Modern motorcycle helmets are complex bits of engineering. They need to protect the rider in all kinds of crashes, but they must be light, offer good visibility, be comfortable, aerodynamic, and act as a sound dampener. That's why designing a new helmet can take between 2 to 3 years. Here, a researcher is testing a new helmet in an acoustic wind tunnel, which is used to gauge aerodynamic performance and noise levels. This tunnel can generate gusts of up to 230 kilometers per hour. It's like an indoor cyclone. Wind noise is a serious threat to a motorcyclist's hearing. Without protection, at 100 kilometers per hour, the driver would experience up to 100 decibels of noise just from the wind. Prolonged exposure would deafen you. Using the wind tunnel tests, Schuberth have been able to reduce noise levels in their helmets by 15 to 20 decibels. It's also important for a helmet to be aerodynamic. At 200 kilometers an hour, a poorly designed helmet exerts the same drag force as a 10-liter bucket of water hanging off the back of your head. So, back in the lab, a thin line of smoke is used to show how the air streamlines around the helmet. Experts can see how the airflow shifts when the wind changes direction or the rider's head moves. The other problem is bad weather, greatly increasing the risk of an accident. So a new helmet design must be put through its paces in a rain tunnel to see how it copes. The results of all these tests are then fed into the computer, and the designers are able to make subtle alterations to the shape and structure of the helmet. After testing and tweaking and more testing, the new helmet design is finally sent to Schuberth's assembly plant, an hour away in Magdeburg. Production begins with reams of fiberglass cloth. It may seem strange, but this cloth will soon be transformed into the incredibly tough outer shell of the helmet. The high-carbon steel knife follows a pre-designated pattern, slicing through up to 15 layers of fiberglass cloth at a time. The secret to making the fiberglass strong is hidden within this molding press. Forget robots. At this stage in the process, every helmet is made by hand. The cloth is placed carefully around the walls of a mold. Then resin is used to coat the inside of the cloth. Then a lid with a silicone balloon is lowered. The balloon expands, forcing the resin and cloth against the walls of the mold. The whole thing is then cooked at 80 degrees Celsius. The heat causes a chemical reaction, fusing and baking the resin and the fiberglass, turning flimsy cloth into an incredibly tough casing. The shell is ready, but it needs a haircut. For that, they use an extraordinarily accurate and powerful jet of water. The helmets are loaded and locked into a kind of vise called a jig. They're then swung round into an enclosed cutting booth. It's then safe to turn the water jets on. Each water jet is cutting with a pressure of over 50,000 psi. That's 2,000 times more pressure than you'll find in your car tires. These jets are so powerful, they can cut through granite, marble and steel. Fiberglass is child's play. The next step is to sand off all the bumps and ridges using mini sanders before the helmets are painted, again by robots. The paint is flash dried under ultraviolet light. Now the outer shell is ready for final assembly. A rider's life depends on the helmet, so each helmet is assembled meticulously by hand. It takes 20 minutes to put a helmet together. Time for the protective inner shell. The cheek pads, the chin guard, some neck protection, and the visor. A last check to ensure everything is working smoothly. And the helmet is ready. Even the most cautious motorcycle rider can't be sure they won't be involved in a terrible accident at some point, but they can at least get ahead of the game with a well-engineered crash helmet.